Okay, so I'm back talking to you about your section 1.1 linear equations section. The last little bit of your homework and the last section of your notes that you'll see have a topic called solving for a specified variable. So you have a bunch of equations that we're going to basically be rearranging. Whereas the earlier assignments, the earlier problems, we were solving for x and getting like x equals a number, a final answer that we could check. Whereas on these, we have too many variables. You can't really solve an equation definitively, like get an answer for it, like x is 2, if you have too many variables. So that's what we're going to see here. We're just going to be rearranging the equations in different orderings and kind of playing with our algebra rules. The same rules we've been doing, but we won't get like a definitive answer, just a rearranging. All right, so some equations that we use, some formulas that we use this semester. The first one is interest equals principal times rate times time. This is a business application. The interest that you earn or you pay on money, depending on if you're saving or you're borrowing, is how much principal, how much money you borrow, times the rate of interest times the time. Those are the three factors in that. And we could rearrange that equation. For example, if we rearranged it for the t variable. That's the kind of thing you'll do in this part of your homework. Just rearrange it. To get t alone, because these are multiplied, we could divide by p and r. And we would have, if we had a bunch of calculations to do in terms of time, it'd be time is I over PR. It's the same equation, just in a different form, rearranged for time. Time is always the interest you pay divided by the principal times rate in the denominator. Equivalent equation, just a rearranging of it. So that's what we're doing on this last little section. Another formula is the distance formula. Distance is rate times time. You know, the distance that you drive, for example, in a car would be how fast you're going times how long you go. So the rate, say it's 60 miles an hour for 2 hours, you'd multiply 60 times 2, you'd go 120 miles. So distance is rate times time. But if you were going to do a bunch of calculations for time, for example, if we were solving for t, we would divide out the r on each side. And we can say time is always the distance over the rate. So in my little example, if you drove 120 miles and you were going 60 miles an hour, that divides to be 2 hours. So it's just another way of rearranging exactly the same idea though. The next formula, we're going to use that for graphing in the next chapter. Y equals mx plus b is our formula for slope and intercept of a line. So that can be rearranged, solving it for m, for example. If I were solving for m, I would throw the b across the line, have y minus b. And then again, solving for m, then I would divide by x. And the slope, m, is always y minus b over x. Same equation, rearranged. One more time, this is a geometry example. This is the perimeter of a rectangle. It's twice the length plus twice the width. We could solve it, let's say, for L, get L alone. I would bring the 2W across, and it would make P minus 2W. You can't really subtract them, so you just write it as that brought across. I'm solving for L, so I want the L term alone, so 2W is like a constant to me. It doesn't have the variable I need in it. It equals 2L. Then I want L alone, that I can divide by the 2, and the L value will always be the perimeter minus 2W over 2. So again, a rearranging of the formula. Okay, on the next page, we've got some practice problems, a couple more examples of that. And I do that same one, the top of the page, so let's go on down to the next example. And I'd like you to try this one. No special formula for this. This is just some random variables to practice it. We're solving for x. So take that equation, rearrange it so you've got x equals everything else. So we'd have 2x minus 2a plus b. Again, too many variables on this to definitively solve it and get a number answer. But notice none of these combine. Nothing combines on that side. So I've simplified as much as I can. So I'm ready to move things across the line. So I want anything that contains an x. If I'm solving for x. Whatever you're solving for, you want to gather that to one side, and anything that doesn't have that letter, throw it to the other side. And we know when we throw terms across the line, we just make them the opposite sign. So I'm going to get the x here. I'm going to bring this x to the right side, so it'll keep a positive 1x there. 3x minus 2x is 1x. That's all the x's I see. And then this a needs to go the other way, making it minus a. So we've got negative 2a minus a, which is negative 3a, and b equals 1x, which is just x. So that solved it in terms of x. Okay, next example. We have surface area, or S, equals a whole bunch of terms. This one has 3 terms for the formula part. This is actually a geometry formula. This is the surface area for a box, basically. You'd add up all the different sides. Each side would have an area of length times width, or the 2 dimensions, and there'd be a top and a bottom. So not that we need to know that. We're not doing geometry class, but this does actually connect to something real. But we're just going to rearrange it for the H term. Make my H look more H-like. So get H alone. So anything that doesn't have an H in it, we're going to throw to the other side. So there's actually 2 terms with an H. Do you see this term and this term both have H in them? So they're going to stay put. This term that doesn't have an H, throw it across, making it minus 2LW. We won't really be able to combine those like we like to do, so we just have to leave it like so. I don't know why I'm making one of my H's cursive and the other one not, so sorry if that's confusing. They should both just be regular H, cursive or not. So I've gathered my 2 H terms, and anything without an H is on the other side. And I can't combine these H terms. This is the first time this has happened in any of my examples. If you can't combine the letter you're trying to solve for, like normally we have 2x and 3x, and we just say it's 5x. We just combine it. But I can't combine these terms, right? Not like terms. So the strategy when you can't combine the terms you're trying to solve for is you have to factor. So I factor this H. It's in 2 terms. So I'm going to factor H out of it. It leaves 2W. Notice H times 2W would be 2WH. Then over here, H times 2L will be H2L, or 2HL in any order. But I've pulled that H out of the 2 terms that has that. That's factoring that out. The other side, leave it alone. Almost done. This is times this quantity, so just like always, we can divide by what's with our variable we're trying to solve. So we divide that on each side. And then that is your final answer. H equals this mess. S minus, it looks like we made a mess, but it is correct algebraically. We've done what we were set out to do. Get it rearranged in terms of just H. H on one side, everything else on the other. All right, so the big thing there is if you can't combine, you factor. Factoring. Okay, we got one more example. I want you to try it first. Try using this strategy. And this is actually a business formula, so this one's a real formula. And we're going to rearrange it for P. We're going to get it in terms of P. So again, always be pausing that video and practicing on your own. And also I should say, if you have fractions or decimals, that's always step 1. None of these formulas had a fraction in it, but should you have fractions, that's always where we start. Clear your fractions first. Then step 2, distribute if you need to distribute. Then step 3, gather your variable you're solving for onto one side. So whatever letter you're trying to solve for, in this case is P, get your P terms on one side, and everything else throw it to the other side. So we'll notice we have 1, 2, 3 terms. 3 terms. 2 of those terms have P in them. This minus P and this PRT. Those need to be on the same side. So I'll move this over. Now if I was solving for A, I would be like, check, got that done. If it was solving for A, that's it. But I'm solving for P, so we have to keep rolling. So to say we cannot combine those, just like my last example, they're not like terms. Cannot combine. When you can't combine, you factor. So P is in this term, P is in this term, which means it's a common factor, so we can factor it out. Now you do have to show P times 1, put a 1 there, placeholder, P times 1 for that term P. And then P times RT for PRT equals the A that's on the left side. All right, and that's the strategy. That's the kind of trick to solve for a variable. So that's times, so we'll do the opposite and divide by this quantity, that parenthesis, divide it to each side. And now we have followed our algebra rules and got P alone equals everything else, A over 1 plus RT. All right, so that's what I've got for you for section 1.1, and I hope that helps, and I wish you all the best.